is learning from Vedantu.
Now let us start the chapter chemical kinetics. For any chemical reaction, chemists try to find out the feasibility of a chemical reaction which can be predicted by thermodynamics, right? Extent to which a reaction will proceed from chemical equilibrium. C. Speed of the reaction, that is time taken by reaction to reach equilibrium. Please, this is the fundamental of this chapter. This chapter is unlike any other chapter. So once it go into your head, you will be comfortably placed. So I want complete mental presence here, right? I assure you, nobody has taught you chapter like this. So that is my confidence in this chapter. Along with the feasibility and extent, it is equally important to determine the rate and factors controlling the rate of chemical reaction for complete understanding. For example, which factor determine how rapidly the food gets spoiled? How to design a rapidly setting material for dental fillings? Dental filling, you understand, root canal treatments. How to design a rapidly setting material for runways damaged during wars so that fighters can take off. How to design rapidly setting cement for repairs of dam underwater and broken runway. You understand, we have to repair them in a very fast way. We can't wait. What controls the rate at which fuels burn in an auto engine? Right? The branch of chemistry, the branch of chemistry which deals with the study of reaction rates and their mechanism called chemical kinetics can answer all these questions. What is chemical kinetics? It deals with the study of reaction rate, how fast a reaction can go, how can we control the rate of reaction, and their mechanism is called chemical kinetics. Can answer all these questions. Especially girls, right? Listen to me. You must have heard in class 11th that graphite, this is energy beta, and diamond. Nahin, that is one application, Shamik. This is diamond and this is graphite beta. Graphite is more stable. Remember it. That means when I convert from diamond to graphite, beta delta G will be what? Negative. Delta G will be negative. Delta G negative matlab this process is going to happen. Carbon diamond will definitely go to carbon graphite. Why? The nature has said that you are going to happen. Delta G is negative. But this reaction will happen in maybe billions, trillions of years. Billions, trillions of years. So listen to my statement. I say this reaction is thermodynamically feasible. But this reaction, who is going to wait for trillions of years? Maybe billions generation will pass. So this is kinetically, Anji, not feasible. Especially girls, right? You must tell your mother after the class. That is why you have heard diamonds are, Anji, forever. They will never change into anything. They are very stable. So if you buy a diamond now for billions, trillions of years, it will not be destroyed. Iron will go, it will rust. Gold will go, right? Anything will go, wood will go, any molecule will go, but diamond will not go. That is the kinetics. So now onward, we have to see every reaction from platinum will go, everything will go, every atom will go, right? But diamond will stay for maybe billions, trillions of years. That will be this. चलो अब आप ये पढ़ते रहना ठीक है जी, जरूर पढ़ना बेटा. So that is going to help you in having an understanding. Diamonds are forever. We have written that. See, so Please, it's a base of the chapter. The better you understand now, everything will be moving at its own pace. All with me? All with me? And this is said to be the most difficult chapter of chemistry. And I assure you that if you are with me, I will make this one of the easiest chapter of chemistry. Sure. Few reactions are extremely fast or instantaneous reaction. आपने पलक झपकाई, रिएक्शन खत्म हो जाए. हम उनके बीच में ज्यादा इंटरेस्ट नहीं रखेंगे. These reactions are so fast that they occur as soon as the reactant are brought together. It is almost impossible to determine the rate of these reactions, right? Rate of such reactions are measured with the help of certain techniques which we will not discuss at your level at all, not even for the JEE advanced level. What to talk about the school level. So fast reactions are ionic reactions. He has asked once upon a time that why ionic reactions are very fast. The answer was no time is wasted. No time is wasted for breaking the bonds, which is the main time consuming of the process. Time consuming step of the process. Okay. Ionic compounds are already completely dissociated when you add in the solution. So no time is wasted. Don't worry about this part. Second is extremely slow reactions. I know once I asked you from where the water has come from on the earth. Can you answer me? How did we get water on the earth? Comets, right? Because if we are going to form water on the earth, it will take trillions of years to form this much of water on earth. So water is not formed on earth. So the rate of reaction is very slow. Carbon plus oxygen forms carbon dioxide. This is again going to be very slow reaction at room temperature. So we practically cannot measure the rate of such reactions. So very fast reactions are gone. Very slow reactions are gone. We will be discussing, then we can increase it. This is also going to be discussed in this chapter. Then we are going to discuss the moderate reactions. What are moderate reactions? Which happens in between these two extremes, right? Those reactions we are going to measure in this chapter. No need to memorize which are moderate, which are fast reactions or which are slow reactions. Whatever reactions we are going to discuss will be in between the limits. For example, decomposition of hydrogen peroxide, decomposition of N2O5. This happens in 1 day or 2 days. Yes. Certainly yes. That is where the catalyst comes. Catalyst, we are going to tell you, it will increase the rate of reaction which are otherwise very slow. But catalyst cannot make a thermodynamically impossible reaction to happen. It will just increase the speed of the reaction with it. The speed of the reaction. Enjoy the chapter. Okay. Rate of reaction. No ratta bete. Nobody is going to ask define rate of reaction, nor I'm teaching you like that, right? I'm going to tell you this type of question is going to come, then you are going to practice that. And yes, now you should practice the test I have shared for solutions with you people. Now you should. Okay, let's see what is going to be the report. Up, as we can express the speed of vehicle in terms of change in position or distance covered by it in certain period of time. Say you are driving a car maybe from New Delhi to Bangalore. I do not know the distance. Say let it be, it is 1500 kilometers. Suppose, although it is more than that. And you have covered this distance in 15 hours. So what is going to be your speed? 1500 by 15. It is kilometer per hour. That is 100 kilometer per hour. That is your speed. Similarly, the speed of a reaction may be defined as change in concentration of reactant or products in a given interval of time. Change in concentration of reactant or product in a given interval of time. Now you see, सुनो बेटे, मैं यहाँ पे समझाता हूँ, वहाँ पे लिखा हुआ है. Suppose we have A moles of A giving you B moles of B. Let us have a graph. On this side we have concentration, on this side we have time. You remember concentration of A reactant will be more initially. This is C. मैं और easy करने के लिए इसको R ले लेता हूं. R for reactant and P for product. That will be even better. This is better reactant. As time increases, बच्चों, so concentration of reactant decreases. And remember, beta, the graph never goes like this. The graph never goes like this. The graph is always like this because at a particular stage equilibrium will be attained. Equilibrium will be attained. No reaction goes to 100% completion. Chemical equilibrium, class 11th. अब देखो, this is for reactant. This is for reactant. Now you see the products. The concentration of product will be 0 initially, बच्चों, and as it increases, बच्चों, it will attain a constant value. This will be the graph for product. And again, product will never go to infinity. It will attain a constant value. That is a stage known as equilibrium. After that, concentration of product and reactant will not undergo any change unless and until you apply Lee-Chatelier principle. Okay. So I hope now you know when this constant happens, equilibrium has been attained. So now, beta, I have to use it maybe 10,000 of times in your chemistry. ROR, finally, we are going to abbreviate as rate of reaction, right? We will be using this convention, this abbreviation throughout the chemistry, but you should not use this abbreviation in your school test. Remember, इसको यहीं पे लिखना है. Rate of reaction. Rate of reaction can be taken as, अरे ROR is rate of reaction. अभी तो कुछ बताया ही नहीं. Rate of reaction is, हाँ जी बेटे, rate of change of concentration with respect to, हाँ जी, time. With respect to time. Now, how can you measure the rate of change of concentration? You measure the slope. If you measure the slope, what will be this, बच्चों? Delta C, rate of change of concentration. What will be this? Delta T. So you can write it delta C by delta T. समझ आ रहेगा? Rate of change of concentration by divided by time taken for that change. Or in a better way, can't I write it? It is delta R by delta T. ROR. What is ROR? Rate of reaction. Delta R by delta T, and it can also be taken as delta P by delta T. What is rate of reaction? It is rate of change of, this is a sign for beta, concentration with respect to time. Jitni concentration change hui, divide it by time taken, that is nothing but rate of reaction. If this time period is going to be less, then the rate of reaction will be fast. If the time period is going to be more, so this is going to be it. अभी कराता हूँ बेटा, अभी कराता हूँ प्रथमेश. Just give me a few seconds, beta. I'm just introducing that. Now we introduce a concept known as, अभी लेके आ रहा हूँ बच्चे, active mass, or that is known as प्रथमेश molar concentration. That is nothing but a moles per liter, the molarity which we had discussed in the first chapter, capital M, right? And it is a convention to write concentration of substances either in square bracket or C subscript. That is, I'm going to the next page. Suppose we have, say, A moles of A, अभी रुक जाइएगा, A giving you B. Then rate of reaction, ROR, can be written as dA by dt or dB by dt. समझ आ गया? This stage, you remember from your mathematics or maybe from physics also, as delta T approaches 0. So that is going to give us a better result. This delta A by delta T will look like dA by dt. That's a better term. And it is d delta B by delta T will be what? Differential of B by differential of T. right? That is, we can write rate of reaction as it is dA by dt dB by dt. Correct? From delta we have brought differential. From square bracket we can write it like this. It's a convention, right? Now another thing, if you see this graph, the concentration of reactant is decreasing with time and concentration of product is increasing with time. To compensate the negative slope, we are bringing negative sign in terms of reactant term. We will put a minus sign. Why you put minus sign? To compensate the negative slope or decrease in concentration to negative slope. This is the case. Right? More concept. Please do not memorize. We will be just solving numericals. Nobody is going to ask you how are you going to write that. ये तो basic concept चल रहा है बेटे. सुनो, ध्यान से सुनना. It is H2 gas plus I2 gas equilibrium 2HI gas. आपने equilibrium नहीं भी लिखना, I don't mind. In this chapter there is no need to write equilibrium. You can write like this. But ultimately तो equilibrium ने तो आना ही आना है. हर reaction तो equilibrium पे आएगा. एक सेकंड बेटा. See बेटा, between you and me आपको समझाने के लिए. Let this reaction completes in T is equal to say 10 minutes. सिर्फ आपको समझाने के लिए. Nobody knows how many minutes it will take. Listen to my statement. Listen to my statement, please. It will be base once for all. उसके बाद आपको वापस आने की जरूरत नहीं. In this reaction, 1 mole of H2 will go in 10 minutes. Will go. 1 mole of this will go in 10 minutes. Do you understand? But in the same time 2 moles of HI will form in 10 minutes. ये बात समझ आई? राइट? स्टाइकोमेट्री देख के बताइए ना, इसका कितने मोल्स हैं बच्चे? 1. इसके कितने हैं? 1. इसके कितने हैं? 2. So if the same time 1 mole of this goes, 2 moles of HI will be formed. Right? Yes or no? This is the basic fundamental. Yes, no doubt. अब देखो, मेरी बात को ध्यान से सुनना. Once for all, the rate of disappearance of hydrogen is half than the rate of appearance of HI, or rate of appearance of HI is double, 2 गुना with respect to H2 and I2. Right? You remember our interest is in the reaction, not in individual change of concentration of hydrogen or iodine. Right, Prathamesh? Therefore, to give unique value to rate of reaction, we divide each term by its coefficient, by its number of moles. It is differential of H2 by dt. माइनस साइन पता है कहां से आएगा? 1 by 1. It is minus of differential of I2 by dt, and it is plus 1 by 2 differential of HI by dt. Right? Why we have done this? Why we have done this? Because we want to have a unique value of rate of reaction. Right? It is HI will be, its rate of disappearance will be double than that of this. Now, R of them have become equal to rate of reaction. That means for a general reaction, A moles of A, B moles of B gives you C moles of C, D moles of D. What is this, Vedantu? The stoichiometric. How do we write its rate of reaction, Vedantu? It is 1 by A. It is differential of A by dt, मैं माइनस साइन अभी डाल रहा हूं, b differential of b by dt, you have to put a minus sign here, right? And then you have to write 1 by c differential of c with respect to this, it is d, it is differential of d with respect to dt. That will be the expression for the rate of reaction, and this is known as, अभी बताता हूं, differential, अभी बताता हूं बेटा, differential rate of equation, differential rate of reaction. You are asking minus beta because minus sign indicates concentration of reactant is decreasing. Plus sign indicates that the concentration of product is increasing. So to compensate this, the concept of division is there to bring them all equal, right? To bring them all equal. Please do not memorize. Just give me time. When we are going to solve numerical, this will be the most easiest chapter of the easier topic of the chapter. You please read it quickly. Rate of reaction, only the important thing will be decrease in concentration of reactant or increase in concentration of product by time taken for the change. The rate measured over a long time interval is known as average rate, and the rate measured for infinitely small interval is called instantaneous rate. You must have done it in class 11. You are driving a car at a particular state, its instantaneous speed might be 500 km per hour, might be 200 km per hour, it might be stationary also. But the average speed of the car was what? It was 100 km per hour. Average. Right? A particular instant of time. So this I have explained everything to you. No need to think that it can be asked in theory. This is units of rate of reaction. Units of rate of reaction. Units for rate of reaction. See beta, what is rate of reaction? It is dc by dt. Although we are writing differential, but we will never do the differentiation. We will simply do delta by delta t. Right? It is going to be, what is the unit of concentration? Mole per liter. What will be this? Second. Right? You can write it mole per liter per second. You can write it capital M second inverse. Do you understand what is capital M? Moles per liter. Very soon we are going to discuss rate of reaction is going to be rate of change of pressure. Rate of change of pressure. Okay, I write in something another form. It is rate of change of pressure divided by time. So what will be the dimensions? Atmosphere per second or bar per second. Atmosphere per second or bar per second. Please do not memorize anything. कोई रट्टा मारने की चीज ही नहीं आई इस चैप्टर में. बहुत कम अगर कुछ हुआ मुझे वो भी नहीं लगता है. So we are going to learn this chapter by solving problems. That is the way. And I'm again assuring you again and again, it will be very easy. Let us see the practical problems. We will not write anything. I will just discuss with you. Rate of disappearance, mercury, chlorine and this. So do you understand that why he has skipped minus? So there will be minus sign क्यों होगा? It will be because these are reactant. There will be minus sign beta. Okay, I write like this. It is rate of reaction is going to be minus of, it is rate of change of mercury with respect to T, and it will be minus of D Cl2 by dt, and it will be plus, it is HgCl2 by this. Summarize. If the stoichiometric coefficients are different, that doesn't make any difference beta. That doesn't make any difference. No difference at all. Physical state might be different. Doesn't make any difference. Right? So कोई फर्क नहीं पड़ता है. अब ये देखिए, it is 2, it is this 1 and 1. So we have written 2 here. Do you understand 2 क्यों लिखा? Now do you understand minus क्यों लिखा? हाँ, Positive for products and negative for reactant. Why? Because product slope is increasing and reactant slope is decreasing बेटा. And here it will be positive. थोड़ा समय दो शौमिक, अभी और समझ आ जाएगा माइनस प्लस का क्या मतलब है बेटे. थोड़ा समय और दो, हम न्यूमेरिकल्स में से निकलेंगे बेटे. This is the case. Do you understand this? Oh, no problem मेरे बच्चे. You're most welcome बेटा. Keep on asking. Do you understand this? Try to understand 5, try to understand 6, 3 and 3. Try to understand minus here also and minus here also beta, plus here. Correct? चल सकता हूं आगे? Let's see क्या लेके आ रहे हैं हम आपके लिए. अरे वाह, ये तो प्रॉब्लम में आ गई. अपना पेन रेडी और कैलकुलेटर इकट्ठा करो. Bring your calculator closer to you. Read the statement. हाँ बेटे, it's a basic problem. That's my strategy. Built from the base, take you to the top. Right? Once you do these questions, I will upload the NCERT problems also. Right now in the next class, you will be getting NCERT problem. नहीं, Aston देखो बेटे. From the concentration of butyl chloride at different times given below, calculate the average rate of reactions during different intervals of time. See बेटा, see. अब ध्यान से सुनो. माइनस का मतलब समझ आ जाएगा. On the board. माइनस का मतलब अपने यहाँ समझ आ जाएगा मेरे प्यारे से बच्चों. Rate of reaction. It is reactant ना. Minus. What is this? Final. What is final? 0.0905 minus 0.100. I'm taking this divided by time bete. Kitna second? 50 second. This is between this and this. So now I'm calculating between this and this. Keep on watching. Use calculator when I ask. This is final. Minus 0.741. 0.0741. एक मिनट कहीं गलती ना हो जाए जब आप सॉल्व करेंगे तो ढंग से लिख लेते हैं. 0.0741 minus 0.0820 divided by how much beta? 50. You understand 50 कैसे हुआ? 100 minuses. Now let us calculate the rate of reaction for this and this. ROR minus 0.0549.0671 divided by 100. क्या है समझ आया? Let us calculate. This is 400 and 700. Please help me out. Rate of reaction is minus बड़ा. Correct? By how much? 100. Now last one. Rate of reaction minus. Why minus? Because reactant. Minus of ये minus क्यों लगा दिया? It is 0.017 minus 0.210 by बच्चों 100. You got it? Now you understand. This is smaller. This is larger. हाँ, I'm taking nearest because he has asked during different intervals of time. So this minus will become. I'm taking any two beta. Any two. You could have taken, he did not ask, but he asked during different intervals of time, during this to this, during this to this, during this to this, during this to this. It is not a difficult question. He's building up. He could have asked between this and this, but right now I'm telling you the rate of reaction. Can you tell me the answer? 1, 2, 3, 4, 5. मेरे से गलती होगी बेटे. Sorry. इसमें तो sorry बेटे. इसमें 300 आना था. इसमें तो कितना आना था? 300. 700 minus 400. Yes. चलो, give me the value first. Point 0009. 0.0009. 1, 2, 3. 0009 चौमेक. Value 2. सेकेंड वैल्यू बच्चों Minus minus will cancel out. You simply subtract this from this. That will give you positive value. You subtract this from this. Point 0.00012 15. 0.015. This is a problem from your NCRT. I have taken from NCRT, so I do not know where I have kept the book. चलो कोई बात नहीं. Tell me value 3. Dev 0.00012 Rakesh. Acha, Nayan is giving us the scientific notation. No problem. Value 4. Triple 0.76. नहीं बच्चे, मैं एग्जैक्ट वैल्यू शेयर आप मुझे दे नहीं रहे हैं. मैं जस्ट वांट टू सी द बुक. Where has there is a book. I'm taking the NCRT book. You don't please pick the NCRT book. I will give you the answer. हाँ, 0.09 into 10 to minus 4. It is 1.7. It is something like this. This is something like this. हाँ. So I'm taking the value from your books. This is 1.9 into 10 raised to power minus 4. And I'm taking that values. It is 1.7 into 10 raised to power minus 4. I'm taking the solved values. It is 1.58. Something like this into 10 raised to power minus 4. And this is simply 4 into 10 raised to power minus 5. Okay. Anyway, don't solve it. I hope you understand the concept. I hope you understand the concept. It is rate of change of concentration. Leave it, beta. Leave it. Right? Leave it. It is rate of change of concentration by time. अच्छा, एक ना ज़्यादा confusion आ रहा है, मैं उसको समझाता हूँ. सुनो बेटा, सुनो. Reactant giving product. Please do not copy. At इसी तरीके से देता हूँ. Right? T is equal to 0 and so on. Here he gave T, here he gave concentration of reactant. It is 0, 10, 15 and 20. It is concentration of, I'm giving you reactant, concentration of reactant. You understand reactant will go on decreasing. It is 20, it is say 10, it is 5 and it is say 2. You want to calculate the rate of reaction. So what is rate of reaction? It is final concentration minus हाँ जी बेटे initial concentration by time. अरे यही होगा ना चेंज तो. What is final? 10. What is initial? 20. I'm concentrating on this. By T is 10. It will be minus 10 by 10. Can rate of reaction be minus? No. So that is why to equalize it, he is writing minus here. That will become this. Now you see, let it be, if he gives concentration for product, reactant to product, T is equal to 0, 10, 15, सिर्फ मेरे और आपके बीच में. Concentration of product, this is going to be increasing. 0, say 5, say 10 and say 30. What will be better rate of reaction? It is final 5 minus 0 by 10, 0.5. So it will be positive. Rate of reaction can never be negative. So to compensate the decreasing concentration of reactant, he is putting which sign? Minus sign. समझ आया? Otherwise rate of reaction क्या आना था? Rate of reaction will be minus. That is why he is putting minus sign in front of the reactant term. Reactant term. चलो जी एक और क्वेश्चन करके देखते हैं, शायद आप ज्यादा अच्छा समझें. Because बेटे से this thing concentration, एक सेकंड मैंने यहां पे कहीं समझाया था ये. अच्छा चलो एक और केस करते हैं. It is N2 gas 3H2 gas gives 2 ammonia gas. Let this reaction be covering in 10 minutes. So in 10 minutes 1 mole of nitrogen will go. That means rate of disappearance of nitrogen will be equal to rate of reaction, क्योंकि वो भी 10 मिनट में जाएगा. तो rate of reaction is minus of, it is, मैंने जानबूझ के C लिखा है, हम ऐसे भी लिख सकते हैं, by dt, although square bracket will be more commonly used. But now you see, in 10 minutes 3 moles of nitrogen will go. So rate of disappearance of hydrogen will be triple the rate of reaction. So we have to divide it by 3. एक मिनट रुको, अब अपने आप सोच के बताओ, will this term be equal? Will this term be equal differential of hydrogen by dt? क्या ये इसके बराबर होगा? No, because this is 3 times faster than that. So to make it barabar equal, we divide it by 3. समझ आया? अब ये देखो, if I write it is rate of disappearance of ammonia or dt, क्या ये दोनों बराबर होंगे? No, this is double than that of this. So you have to divide it by 2. So to bring it in rate of reaction, we have to divide it by stoichiometric coefficient. That is going to give you the unique value. Unique value. Bring your calculator, right? I will solve the question. You will calculate for me. Read the statement. Have you read it? Have you read it? Sure. When the kinetics comes, you must understand that you are growing up. This is the challenging chapter of 2-year chemistry, right? But keep on revising it, beta. It's very easy, really very easy. Unitary mathematics पे काम करवाऊंगा. Unitary mathematics कोई formula नहीं ज्यादा रटने दूंगा. So he gave you concentration of N2O5. तो it is differential of, differential बोलते हैं but हम ऐसे ही लिखते हैं, by dt. Beta, it is reactant, तो can I write minus? Correct? Now minus, what is the final concentration? 2.08. What is the initial concentration? This is 2.33, right? It is what? Mole per liter. What is the time, beta? 184 minute. So what will be this? 0.25. अरे 0.25 ना, because minus minus तो cancel हो गया. Divided by 184, this will be, Hanji, it is capital M per minute. Can you give me the value? Give me the value. 0.25. I'm using calculator. 1.35, you're right बेटा, 1 2 3 into 10 raised to power, अभी आ रहा है शामिक, अभी इंतजार करो, -3 बेटे. It is capital M per minute, right शामिक? 1.35 into 10 to -3. Did he ask rate of disappearance of N2O5? No. He asked, Shamik, he asked मेरे बच्चे, the average rate of this reaction. So beta, rate of reaction will be half, right, of, it is differential of Hanji N2O5 by dt. That is going to be 1/2 into 1/35 into -35. Do you understand that? It will be how much? It will be 0.675. So, nahi, 1.35 by 2. Rate of reaction, हाँ, और that is 6.75 into 10 raised to power -3 mole per minute. क्या ये समझ रहा है? He asked rate of reaction. You have to divide it. अब दोबारा देखो, इन टर्म्स ऑफ आवर्स तो आ गया, इन टर्म्स ऑफ मिनट्स, व्हाट इज रेट ऑफ रिएक्शन? 6.75 into -4 divided by per minute inverse. 1 minute is equal to 60 second. This will be your answer. Got it? This will be answer in second, mole per second. Get me the value. Get me the value. I'm just opening your book. हाँ जी, इट इज सेकेंड में आ रहा है 1.13 इंटू 10⁻⁻⁵. परफेक्ट. व्हाट इज दैट? मोल पर सेकेंड बच्चे. हो गया. नाउ 6.75 इंटू -4 मोल पर मिनट था. आई वॉन्ट टू कन्वर्ट टू आवर्स. यू रिमेंबर 60 minute is 1 hour. This goes. Get me the answer in hours. .05 Shraddha. 4.07 into -2. सो मेरे प्यारे से बच्चों, ये चीज समझ आई? दिस वॉज रेट ऑफ गुड़िया डिसअपियरेंस ऑफ N2O5. दिस वॉज रेट ऑफ डिसअपियरेंस ऑफ N2O5. दिस इज बच्चे रेट ऑफ रिएक्शन. सुनो, दिस इज रेट ऑफ डिसअपियरेंस ऑफ N2O5. करेक्ट. तो ये क्या हुआ? रेट ऑफ रिएक्शन. Now he has asked one more thing. I'm sorry, मैं कंजूसों की तरह एक्ट कर रहा हूं because I have to write here. I can't go to the next screen. अब सुनो, what is the rate of production of NO2 during this reaction? Rate of production of NO2. सुनो, please listen to me. जितने टाइम में N2O5 के 2 मोल्स जाएंगे, उतने टाइम में NO2 के 4 moles बनेंगे. That means rate of formation of NO2 is double the rate of formation of this into 2. So that is 2.7 into -3 into -3. What is that? It is rate of change of NO2 by delta T. It is 2.7 into 10⁻⁻3. Okay, this is known as fundamental. दिव्या, फंडामेंटल, द बेस, द फंडामेंटल. धीरे धीरे करके बढ़ते हैं. नेक्स्ट क्लास में ऐसे लेके जाएंगे, यू विल सी. बट यू प्रॉमिस दैट यू हैव टू रीड एवरी सिंगल वर्ड. हाँ बच्चे, यश, he gave us this concentration final. I picked here. यहां से उठाई, ये फाइनल थी और ये इनिशियल थी बच्चे. अच्छा, लास्ट स्टेप में इट इज रेट ऑफ फॉर्मेशन ऑफ NO2 इज डबल द रेट ऑफ फॉर्मेशन ऑफ N2O5. राइट. नो, N2O5 का कितना कॉफिशिएंट था? उसने N2O5 की वैल्यू दी थी, डिवाइड करेंगे 2 से. अगर सपोज NO2 की वैल्यू देता तो डिवाइड करते 4 से. अगर वो O2 का बताता तो डिवाइड करते 1 से, यानी कि किसी से भी नहीं. ये बात देखो ना, उसको रेट ऑफ रिएक्शन में लेके आना था. ओके, रेट ऑफ रिएक्शन ऑफ NO2 यू हैव टू मल्टीप्लाई बाय 2. हाँ, N2O5 के लिए 2, NO2 के लिए बाय 4 रेट ऑफ रिएक्शन पे लेके जाने के लिए, और इसके लिए O2. करेक्ट. सॉल्व दिस वंस अगेन. दिस क्वेश्चन will be for you people as a homework. Average rate of reaction means rate of disappearance of concentration of reactant or product, divided by number of moles. After the class, you're going to solve this. No, rate of production is rate of disappearance depending upon coefficients. Depending upon coefficients. So now it was 2N2O5 forming 4NO2. I think 4NO2. I think that was the equation plus O2. That was the case. Now rate of reaction is going to be 1 by 2. It is differential of N2O5 by differential of time minus. It is equal to 1 by 4. It is, ये मैं स्क्वायर ब्रैकेट क्यों लगा देता हूं, differential of NO2 by dt, और it is equal to 1 लिखने की जरूरत ही नहीं है, differential of O2 by dt. See, you calculated rate of reaction. You calculated this NO2. This as 1.35 into minus 3. As 1.35 into 10 is to power minus 3. So what is going to be the rate of reaction? You understand that is the case. Now you can equate these two. So this is minus 1 by 2, 1.35 into minus 3 is equal to 1 by 4. It is differential of NO2 by dt. So if you want to calculate this, then what will be this? It is going to be 4 by 2. It is 4 by 2 and it is 1.35 into minus 3 is equal to dNO2 by dt. That's he has asked in the third option. Rest all he was shifting from one thing to another, right? ये यहां से था. दोबारा समझो यार इसको. It's a very basic question. अभी तो ये इसका difficulty level is only 1. इसका difficulty level is only one. So go for the basic and please do solve it. Solutions are present in your any NCERT book. Do solve it. अब देखो तो करना जरूर बेटा, बार बार करना, आ जाएगा समझ, कुछ भी मुश्किल नहीं है. दिस इज सिंपल. देखो क्या चीज है. इट इज फाइनल माइनस इनिशियल डिवाइडेड बाय टाइम टेकन, और इफ यू वांट टू कैलकुलेट द रेट ऑफ रिएक्शन डिवाइडेड बाय नंबर ऑफ मोल्स. दैट्स इट. चेंज इन कॉन्सेंट्रेशन बाय टाइम डिवाइडेड बाय नंबर ऑफ मोल्स. मेंशन द फैक्टर्स दैट अफेक्ट. अभी बताता हूं देव इसके बाद. द रेट ऑफ अ केमिकल रिएक्शन इसके बाद बता रहा हूं बेटा. Factors affecting rate of reaction: concentration, temperature. You remember this thing only. CNT, CR. Concentration. This is a Guru Mantra. CNT concentration. N for nature. T for bete. Don't mind my handwriting. C for catalyst. And R for radiation. Right? Just remember these five. Rest all are included into this. Rate of reaction depends upon how many factors? 5 factors. What is the Guru Mantra, bachcho? CNTCR. You are going to write the board test also. So then it will be required. CNTCR. Concentration, nature, temperature, catalyst and radiation. That's it. Please, बाकी कुछ मत करना. इसके बीच में ही आ जाएंगे सारे के सारे. अपने आप कवर कर दूंगा.